I decided the next radio I'm going to repair is going to be this Jade right here. And I got to noticing something. The box for this one says J185. This one says it's a 162, which presumably would be an older model. There's your price tag, $3.87 from Gibson's, if that's original. I've never heard of Gibson's. But I was really confused because it says 6 transistors, but it obviously has way more, so you would think they would have advertised it that way. And then I noticed that picture, it does not look like this radio. It doesn't look like the radio that's in this one either. And so, yeah, I looked at the back. I mean, it's a J102. So it's not, somebody had these boxes, which is cool, but this is not the box that this came in. And I don't think this one is the original box either. I mean, it's a Jade. It's just a way older model than this. So anyway, I'm gonna, this one's got, as it says, it's got 10 transistors in it. And I looked at it for a second a while ago. And they're all silicon except for this one and this one. I'm guessing this one's being used as the detector diode. They've got 3 transistors right up here around the mixer oscillator. I don't know, and I have no idea what they have going on here. I'm gonna try to take a look at this schematic, and so I can at least kind of figure out what's going on with all these extra transistors. But before we do all that, I'm gonna go grab my voltmeter, and we'll power this up and see how much current it's using and if it even makes any noise or anything like that, and we'll go from there. Okay, let's try it and see what happens. Make sure something didn't come unplugged. Everything seems to be connected. Maybe we've got a blown fuse here. I don't know. Nothing. Well, that's hooked up good. Yeah, I'd say we got a pretty big problem then, because it's not using any current. It's not even a glimmer of hope. Okay. Well, take a look. We were having some technical difficulties, as in technically, this is difficult. So I think I got everything straightened out. But yeah, so if I'm looking at this right, it's using about 3 milliamps, which it doesn't matter whether the volume's all the way up or down. Makes absolutely no difference. There's no noise coming from the speaker, anything. Yeah, just straight up 3 milliamps, which I guess would be about what maybe the oscillator would be using or something if it was running. So at first I thought there was a short, but I don't think, or at least Yeah, it doesn't look like there is now. Maybe there was a short that was so bad that something burned up and now there's no short. But I don't think that's what happened. I think there's definitely something wrong. I don't know if I want to get my oscilloscope and see if the oscillator's running or if I want to get a signal chaser. Or a signal generator. I think I'm going to get a signal generator because then maybe I could kind of like figure out like, is the audio section good, and just kind of go from there. So I think I'm just going to, I'm going to do that, get the signal generator, and then we'll just start randomly poking stuff and see what happens. Okay, I've got my signal generator going, 1 volt at a kilohertz, and let me get all this back. This is pretty hard to do behind the camera. So that's down there near the audio amplifier. And if I come up here near the volume control, it gets louder. And then, as I come, I don't even know where I'm probing, but just somewhere over here toward where the oscillator is. I'm getting something. Everywhere I probed over in here, I didn't get anything, but so now I'm kind of wondering, maybe the oscillator's not running. So I think the next thing to do is just going to be to hook up the oscilloscope. I don't know, I just was kind of hoping or maybe thinking that the audio section would be the problem, but that doesn't seem to be the case. Although I do think there's a bad capacitor somewhere. Well, I'm sure the capacitors that's in there, I'm sure that at least one of those electrolytics, I think there was only a couple. I'm sure they're really bad, but I don't know that it would be bad enough to cause complete, absolute silence. So, and just for fun, I think, we'll just get the scope out and see what happens. Okay, here is the schematic that's on the back of the radio, opposite the battery compartment, and I've been studying it. And here is the converter transistor Q1, and then Q2 it's being used as to set the bias, the DC bias. You can see it kind of goes around that transformer. I guess I kind of could use something to point with here. I don't know how well this is going to work. That's not going to work. We'll use some solder. So this sets the DC bias for this transistor. This is the first IF, second IF, and then this, I believe, is the detector diode. So what I did is before I looked at this schematic, I came to this detector diode and I injected that signal here, and I get no audio at all. And anywhere in the circuit back all the way to the beginning, I've probed all over the place, I get no audio when I inject. but anything past here, as near as I can tell, there's audio. And so if you follow this down, you've got this C6, and then across the, I'm assuming, I think this might be the volume control. You've got C7, which I believe is an electrolytic. And so it's possible that this electrolytic is just completely dead. Because I think this C6 is part of, I think it's part of the detector. The only thing that's confusing to me is I think you would normally see a resistor here as well, and I don't see one, but guess that's neither here nor there. So I'm thinking C7 is just completely open, like super duper open. Must be like the world's worst capacitor, because there's no audio at all on anything upstream of there. And the rest of the schematic, it kind of gets really hard to see, but basically this is like the audio driver, and then they've got, I don't know why there's two transistors there. I guess one drives the other, and then that goes through this audio transformer into this push-pull, and then I can't really see the rest to be able. Looks like there's another transistor up there at the top, maybe. But anyway, so I guess I'll go back to that detector diode and kind of see if I can follow it to an electrolytic and change that and see what happens. Okay, I got that capacitor out in all of its glory. It says Sanyo, not Sanyo, Sanyo on it. 10 microfarads at 6 volts. And that's not cutting it close, right? I mean, it's a 9 volt radio. I guess using 6 volt capacitors, I guess I could see that. and yeah, I do understand that probably that part of the circuit will never, the idea is that it would probably never see anything higher than 5 or 6 volts, but see what we got. Huh. Maybe I get it in there a little bit better. Maybe it wasn't making contact. I mean, we know it's pretty bad, obviously. I mean, I'm pretty sure this thing is bad. The anticipation. I thought I was going to have to get a Snickers bar. Yeah. Well, okay. Well, it says it's a capacitor, but yeah, it's saying a 53 picofarad. Yeah. So, okay. It's definitely not a capacitor anymore. So I'm going to replace that, and if it's okay with y'all, I'm not going to put a 6 volt capacitor back in there. I think we'll splurge, and we'll go for at least a 10 volt. Heck, we might even go for a 16. I might have to check my bank account, see if I can afford that, but we'll get this guy smoked in there, and then we'll see if the radio actually makes any noise. So one thing I didn't say this when we were kind of looking at the schematic a while ago, is the oscillator. I think the oscillator is probably running because there's absolutely no audio whatsoever, and the radio was consuming about 3.5 milliamps. So I mean, something's working, right? And I mean, it's it's kind of got to be the oscillator. It's almost process of elimination. So I'm very hopeful that the oscillator's running. And also, it says on here that the IF should be running at 455 kilocycles. So I think we'll hook it to the scope. Either way, this goes down. All right, I got that capacitor in there, and he was right there. And here's what I believe is the detector, or I say detector diode. It's a transistor that's being used as a diode. I guess that's why they used a germanium, because the bias would be like 0.3 volts. So I guess that would perform better. But yeah, I did end up, I was able to spring for more than a 6 volt. In fact, it's a 63. I don't know if that makes it better, but same amount of current, 3 milliamps. No audio. Okay. Okay, this might be kind of hard for me to kind of do this on the camera, but I can kind of show you what I did. So here's the capacitor that I changed, the electrolytic. And again, when I inject into the product detector with my signal generator, I get no audio. I kind of slept on it a little bit and got to thinking, well, maybe there's an audio transformer that's open. And I don't think that's the case, because when I inject up here, I get pretty good audio. And when I inject further down into the second audio transformer, because this one should be the output, well, if I inject up here, it's actually louder than it is down here. So that kind of makes me think that this part of the amplifier is working. And so this thing is so confounded because there's so many transistors in here, and it's kind of hard to follow the traces on the back of the board. So what I did was I took one of these little hook type leads. These kind of look like oscilloscope probes, but they're not. They're just leads that you can clip onto stuff. They're just straight continuity. And I think these came with I don't know if they came with my component tester or signal generator, but you can buy better ones. These are pretty small. But what I did was I hooked this one onto the positive side of the capacitor, which is the side that is connected to the base of the first audio amplifier transistor, because I didn't know where that transistor was at. I tried to follow the traces and I couldn't find it. And so I did that, and then I clamped the other side to the negative lead of my multimeter. So then I could kind of just take this, right, and then just probe everywhere until I could find where does this capacitor go. And it actually goes to this transistor here. So this must be the first audio transistor, I believe. It's got full continuity to it anyway. But when I inject any kind of signal into there, I get nothing. So if I inject where the capacitor's at, I get nothing. And I can go right to the base of that transistor and get nothing. So my guess is that transistor's bad. Or maybe this transistor is just one that's kind of setting up the bias for another transistor. I don't really know. I mean, I take that back. Actually, I remember on the schematic, this one, I think it's it might be set up like a Darlington pair or something. I can't remember. I think the base of this one is fed by that audio decoupling capacitor, which is, again, it's connected from here somehow, which I believe is the product detector. And so basically it's one transistor that feeds another. So that's probably this big one, and then maybe this black one here sets up the bias. I don't know. These seem to be kind of not really be where I would think they would be. I don't know. But so I think, just because I don't really know what else to do, I think I'll just pull this transistor out, and I think I'll check some voltages first or something, and then I'll pull it out and see if it's any good or not, and then kind of go from there. But the good news is I'm pretty sure the audio transformers are good. So all right, so I've put some time into this. There was a short, and I found it. So I think I'm gonna kind of just try to show you like a little partial schematic kind of. So let's do our plus and our minus here, and then as we come here, I'm not going to draw it, but like I'm just going to draw kind of a block here. This is the audio section, okay? And there was I believe the audio section's in pretty good working order, because when I inject signal into it from my signal generator, I can hear sound fine. And if I go to the first transformer and inject it, it's louder. And if I go to the output transformer, it's quieter, but I still hear sound. And that makes sense because it's being amplified further, the further kind of up the chain I go. So when there was a short, and the way that I found that was I ended up, there's a transistor that kind of sits in between the product detector and the audio section. So if I come down here and draw this, okay, and then let's just say this, is connected to the audio section. That's not exactly how it's connected, but, and then here is an electrolytic capacitor on the input side that blocks any DC bias from coming in. And since I wasn't getting any signal when I injected here, then I said, well, this transistor's probably bad. So I pulled it out. It had an HFE of 23, which seems pretty terrible for a silicon. But other than that, it tested good. It wasn't shorted or anything like that. But I decided it would probably be a good idea to go ahead and just put a modern silicon back in there, because the HFE of 23 seems pretty pathetic for a silicon. In the model number of that, which I couldn't find any information on, was a CS1219E. So I couldn't find anything on the internet about that. But what's happening is when I replaced the transistor, I noticed that I couldn't find any bias current. And so I thought, well, gosh, there's got to be a bad resistor somewhere, right? Because there's probably a resistor here, which I didn't draw. Well, I changed two of those resistors that were in this neighborhood, and I pulled them out. They tested fine. One was supposed to be a 2. I think it was supposed to be a 220, and it was testing 250 or something. I replaced that. Another one was an 8.2K, and it was testing 8.29K. But I went ahead and replaced them anyway. And then I noticed, we would go up here, and there's some up here. You've got just the whole kind of like the whole RF section, right? Like up here, you've got your your converter, your first IF, second IF, all that good stuff, right? Well, no matter where I check, no voltage, nothing. And so I started kind of following things on the schematic, and I noticed that right past the audio section, there's a resistor here. And so all the current that goes to the RF section and this transistor here, it's all got to go through this one resistor. And this was actually that 220 that I changed. So at this point, it's like, well, it's a new resistor in there. And when I probe here, right past that resistor, I get about, less than 1/10 of a volt. But when I probe here, I get full on battery voltage, which, around 8 volts in this case. So you kind of have to, at this point, I was sort of like, this isn't making sense. Like, I'm just stumped. I mean, how could there be this much voltage on one side of the resistor, and especially being a somewhat of a low value of only 220 ohms? And the answer is because of Ohm's law, because there was a short so bad that the voltage drop across this resistor was extreme. And so I had no idea where to search. And basically what I ended up finding was there's another transistor. Every other transistor in this part of the circuit, it has a biasing resistor kind of up here at the top. So in other words, the collector would have a resistor, and then a lot of them, I mean, they all have a resistor going to the base, but some of them also had a resistor on the collector. But kind of let me kind of show you what was going on with that second IF transistor. So it's my poor attempt to draw a transistor, and these are NPNs. So we come up here, and then here's our 220 ohm. And then this just goes straight to ground. There's no, I mean, it's full on current, right? Other than this 220 ohm resistor. And then there's a resistor here to bias the base. So I took this transistor out thinking that it might be shorted or something, and it wasn't shorted, and the HFE tested at 97. It seemed like it was pretty good. And so when I had this transistor out, the short went away. And when I say the short went away, I don't mean by me checking voltages. I mean, if I put my voltmeter here at this point, and then the other side of it, just is connected to ground, the resistance between here and ground it was about 2.5 ohms. But when I took the resistor out, the resistance between here and ground would go up to some really high number like 30K. But I was very, very confused. I mean, I couldn't understand. I mean, okay, maybe you could have some sort of a problem here when the circuit's in operation, but when there's no voltage applied, I mean, it doesn't make sense, especially with a new transistor in there. And so when I would lift this ground up right here, when I just unsoldered it, the short would go away. And there's really nothing else that goes to the trace where this ground hops over, except there's a capacitor. And that capacitor comes between the base and ground right here. And I took that capacitor out, and it was completely open, just 100%, not even a capacitor. It was a ceramic capacitor. I couldn't tell what the value was. It kind of looked like it was a 104, which would be like 100 nanofarads or 0.01 microfarads. and but I don't know for sure. So I put what I've done, because I don't know what capacitor to put back there. I've got these DuPont connectors soldered on to where that capacitor went. And so I'm going to try some different values in here to see if I can find something that works better. I think it's just to help keep just a kind of a filter or stability type capacitor. I don't know how critical it is to the operation of the circuit. I mean, it needs to be there, but I don't know if the value is super, super critical or not. But where the short came from actually was when I replaced this transistor. And again, there was a short here before. I accidentally, because the transistor that I put in there, it was emitter base collector, and I had to kind of twist one of the legs in a funky way to get it to go in, and I accidentally shorted two of the legs together. So that's why there was a short here. So I bent the legs out of the, away from each other, but I think the original short actually, it might have been this capacitor, because it when I tested it in circuit, it did show to be a short. So I honestly don't know what was kind of going on before. I mean, all I know is I'm replacing the transistor and that capacitor, and now I've got it to where there's no short. And so it may have been that capacitor was shorted, and then when I finagled it out, because it was a ceramic capacitor, it just went open. Or it could be that transistor was really bad. It just was testing okay. That seemed kind of odd, but this is where the ceramic and the that's the new transistor that I put in there. So, and again, here's your detector here. And the other transistor that I've replaced or going to replace was the first one that I talked about, which was, it's really, was I going to say that, I couldn't, when I went to put it back, and that's up here kind of, this is where that audio decoupling capacitor is, that electrolytic right there. Well, I kind of got confused on which one was the base and which one was the emitter collector. And whenever I tried to find the voltage for the base and to see where the collector was, well, that's when I couldn't find any voltage at all. And so I couldn't put that transistor back because I didn't know how it went. Without really doing a lot of further investigating, it just makes more sense to figure out where you've got your base voltage and where your collector is, and then, process of elimination, the other one's going to be your emitter. So I'm going to get that transistor back in, and then I'll find some capacitor that I can stick here, and then hopefully we can try him out and see whether it works or not. But this has been quite a challenge. And hopefully while that short existed, it didn't really mess up some other stuff. In the beginning, I was kind of afraid that the audio transformer was shorted or something like that, but I was able to do enough testing to, as far as I could tell, to prove that that's not true. And then again, the final tell was, whenever I would lift this up. And again, I created a short here when I replaced the transistor, but there was one there before, because when I took this transistor out, the short went away. So that, and again, there's this trace here. The way that the trace is physically is you've kind of got like this one circle. Well, it's kind of a circle, and you've got like this long one that's just great, on the side of the board. And normally these would be connected via a trace, but the way they had it was the ground leg of this capacitor and the emitter of this transistor, their legs were kind of here together, and then one of them just reached over to the ground. And so nothing else was going to this trace. So, but anyway, I don't know. Hopefully I explained that in some kind of reasonable way that would make sense. Hopefully, we'll get something to get it to make some noise or do something. I may even have to get another 9-volt battery, because that short, man, it did a number on that battery, like really fast. And I should have been using a current limiting bulb, but I had kind of determined or thought to myself, even though in the beginning I seen the bulb light up a little, I thought, there's no short. I had something wrong, or I don't know. I mean, and yeah, I should have just been paying more attention. I mean, I thought that my meter said that it was using 3 milliamps. Maybe it was using 30 or 300 or something. I don't know. It's kind of embarrassing, but at least I was able to figure out that there was a short and kind of identify the problem. So we'll keep plugging along. Well, I guess this is pretty bad news. I don't know what this says about me. I guess there's not, I'm not, I value humility, but, I guess I'm going to pat myself on the back, but embarrass myself at the same time. So I don't necessarily like it, the idea of people, especially on the internet. There's kind of a tendency for people to portray the good side and never show anything bad or any screw ups or whatever. And there's also that tendency for people to kind of project that, oh, I always knew everything that I know now, and I never made any mistakes type of thing, even if it's just kind of subconscious. But yeah, I think I think I just destroyed the radio. Well, I don't think it's going to be easily fixable, and definitely not by me. So after I shot the last clip, I had power connected, and I was trying to figure out those 2 transistors that I had out, like where's the base, where's the emitter, the collector, so that I could get them in there. And I noticed there was 2 transistors here, which I assumed was a push-pull pair. And I just kind of had my finger here while I was working, and they were getting freaking hot. And so I stopped everything, and especially the one on this side, it was getting really hot. So I pulled it. It went, when I pulled it out, it went flying out of my hand. I have no idea where it went. So maybe I'll find it, but I went ahead and pulled out the one beside it, because if I was going to change one, it's a pair, so you kind of have to change both, or I think it would be a good idea for them to be the same transistor. And it wasn't shorted, and it tested good and all that good stuff. And I was like, wow, this is very frustrating. And after I took the one out, I connected it back to power. The other one, it was getting hot, like really freaking hot. So you would think the transistor would be shorted, but I don't. I guess that wasn't the problem, because again, that transistor tested good. So I decided to pull the audio transformer out, the first stage, the driver preamp audio, and you can see I really screwed it up. There is this lead here that when I pulled up on the transformer, it just left these 2 leads in the board. I mean, it just completely destroyed the transformer. I mean, gosh, I can't. I mean, it pulled up so easy that I thought everything was, and it was just a split second. I mean, it was just, I don't know how they even broke that easy. I really don't. And I don't think this was shorted, because when I checked from the case back to the pins that I can get to anyway, there's no continuity, although there is continuity between one side of this and the other, but it's like really high. It's like 3 mega ohms, which I guess still seems kind of bad, but I don't know. I don't think it was necessarily shorted, honestly. I mean, maybe it was, but I mean, at this point, I don't have another audio transformer like this. I have some audio transformers, but they're not. I don't think they're gonna work in this case. So I don't know. I mean, honestly, this has just really, really frustrated me. I mean, this has went from fun to just, it's at this point, it's not even fun. I've spent at least, and I'm not even kidding, I've probably spent 12, 14, 15 hours working on this thing and have not really been able to figure out. There's something that's shorted, but I don't know what it is. And I think there was honestly two things that were shorted, maybe. And so if I had another transformer, then maybe I would still try to fix it, but I don't. And I mean, I paid even with shipping and handling. What I pay $4 or $5 for this thing. So to me, it's just at this point, it's just probably for parts. I mean, I don't think I want to try to go any further with it. And I mean, yeah, it's just, and the other problem is there's several, I mean, I don't know how many traces that have lifted on the back of all the desoldering that I've done and resoldering. I could work around those. I mean, it's only small pieces of the traces that have lifted, but it does still kind of make it a pain. But I think I don't have any of these spare parts anyway. So I'm thinking just pull these IF cans out. That germanium transistor right there, I could get him out. I mean, and then this audio transformer, all those parts are worth more than $5. And if there's other radios that I can save, I could use those parts, and maybe I could turn my big mistake into a learning experience and just kind of move on. It just, I hate failure. I don't do good with it. And it just, this just really bothers me. Yeah, I don't know. It's very frustrating. And I thought, it's one of those, I don't even want to post this video. It's just because it has a crap ending. But like Stephen King always says, endings are heartless. It's all about the journey. I did learn a lot of stuff. That was cool using the signal generator. I mean, that was fun. That was my first time doing that. And then I know kind of now when I remove a transistor, I'm gonna get me like some whiteout or some paint markers, something to that effect. And I think I'm gonna start marking, putting like a witness mark on them or something, so that if they are good, then I could test it and I'll know which leg went to where. Because it is kind of confusing too to look at this side of the board and flip it over and measure voltages, and especially when you don't know whether some of these if I was lucky, all the ones I pulled out, they weren't really like completely bad. But if one had been like really, really bad, I wouldn't have even really known whether it was a PNP or an NPN transistor, which is kind of scary. But I guess that's just kind of that's some of the stuff you deal with on this. Also the speaker. I mean, I've got this modern speaker connected for now because I didn't want to deal with the wires that had fell apart on the other one, and the wires had fell apart on the headphone jack, which all that's very fixable. And it was an Onkyo speaker, so it's actually like a pretty good speaker, I guess. I think it's on. Yeah, on. I mean, that's one thing that's strange is this radio has some Japanese stuff in it. That one electrolytic, I don't know if I showed that or not, but that thing it said Japan on it. And there was something else in here I seen that was Japanese too. But, I mean, it was made in Hong Kong, but it's got some Japanese parts in it. But yeah, I definitely, I definitely have reached my frustration point. and I think I'm ready to accept failure and learn from it and just move on. And as I'm taking these components out, maybe I'll find something that was shorted, and then I could be like, ha, there was a bad short. At least I found it, even though I can't fix it. So if you see a reprise video in the future, then you'll know that I found something interesting. Otherwise, I guess we'll just move on to the next patient, and we'll just have to triage this one. So the Code Slinger will see you on the next one, hopefully.